Jim McGregor with TIRIAScast Research. We're at the Intel booth, and once again, we're talking about Xeon6 SoC and really the level of innovation that this chip has really allowed in terms of new applications with the integrated AI accelerator and transcoder, as well as just the consolidation, what you can use with it in the RAN or in the edge of the network. So Kevin is joining me today, and he's going to tell us a little bit more about the Xeon6 SoC and some of that server consolidation, right?
Absolutely, a pleasure to be here, Jim. So when we were looking at market requirements and we were defining the Intel Xeon6, one of the key components that came out was that we wanted to make sure we were meeting the capacity requirements of the operators with just a single server. We've had deployments in previous generations where we needed more than one server, and that has implications on cooling and on just the space requirements themselves, which are at a premium at a cell size. So one of our targets was to consolidate to a single server, and we're happy to say that we've got a product here that allows operators to meet their capacity requirements, as well as integrating all of the AI workflows in the future that will be coming to the RAN in a single server, thanks to the increased capacity on our core side. So that's moving from the 32 cores in the previous generation to 72 cores in this generation, as well as the increased capacity for our Intel vRAN boost accelerator, which helps with the layer 1 processing in particular. We didn't stop there though, because energy efficiency is of course a really key portion of this, and the physical space of the components is also a challenge. So we also integrated up to 200 gigabits of Intel Ethernet, so 8 ports of 25 gigs you can have for front haul or back haul, and we complement that with the E830 NIC as well to provide additional front haul capacity on the wider server. So the consolidation we're seeing here is from multiple previous generation servers down to a single server that allows you to have up to 2.4x the capacity improvement over the previous generation, and also delivers up to 70% performance per watt improvement at the same time. So we're really hitting both the CapEx intensive part of it and the OpEx intensive part of it.
So you've got a server here that we're going to look at that has, it's a Xeon6.
Absolutely.
It's a one socket server. So what would the server from the previous generation or previous solutions been? What would that server have looked like?
So those servers, what you typically see on the market is quite a deep server. So it's this is about 300 to 330 millimeters, depending on the final configuration you go for. We typically see something in the 450 to 480 millimeter range. So we wanted to make sure in these space-constrained sites that you had a much neater solution, a much shorter solution to take advantage, and while still taking advantage of the Intel Xeon6 SoC's capabilities. This is a reference design that we've done to help our partners in designing their next generation systems, and we really had some key aspects we wanted to hit in this design. One of the big ones in RAN is thermals. You're in an outdoor environment, you have to meet NEPS compliance, you need to make sure you can cool up to 55 degrees ambient temperature. So we have right here a very clear airflow channel going across the CPU, no preheating involved, no obstruction of the airflow, a nice clean laminar flow to cool that system. We also have the 8 integrated Ethernet ports, as well as some additional ports here through our E830. Really, we wanted to demonstrate the amount of port fan-out you can get within the 1U environment. There are challenges when you're using standard PCIe cards or standard pluggable form factors to actually meet the port capacities you need in this generation. So we wanted to demonstrate just how many ports you could fit in a single solution while still being available, while still being usable on the mass market. And that's why you see up to 20 ports in this 1U solution. And you can also have a 2U version, which we're working on, which allows you up to 36 ports. You don't need that many ports. We're just loading it up with that one. The other really important thing that is not immediately evident is that we've seen a shift on the hyperscaler side through the OCP project, the Open Compute project, to the data center modular hardware specification. This is a modularization effort. Essentially, you're breaking up your server design into multiple components. You have a host processor module for the CPU, you've got different I/O, you've got different management, you've got different power supplies. You're able to assemble these components in whatever way you want. So instead of having a discrete design for every segment, one HBM, you reuse it everywhere, and you change the I/O around it. You have more storage, you have more NICs. What we're working on driving through the OCP is an edge version of that. So that is respecting the depth requirements that we see, respecting the harsh environments that we see that you don't see in the data center side, and trying to work with our OEM partners to develop a specification that they can work to, which enables the same level of reuse, but for a wider range of edge applications. this is our sort of first implementation of a system that is going to be used as a basis for our specifications.
That's awesome. Thank you so much.
I hope it was useful. I hope it was valuable. I hope I was understandable.
You're awesome. Thank you.